It's Mark here. Mark's here! Referring to oneself in the third person. True signs of madness. So I got a question from one of my watchers, Zoe Doucette, was asking for an explanation or a tutorial for the spheres that I created in one of my videos at 3200. So these were, if I fast forward to 3200,
I'd like to talk.
Just need that. Okay, these guys. So how do I make these, and how is it that I'm able to just pull them off so quickly? And well, I'll see what I can do about maybe being a little bit more elaborate about it. So when I do this kind of exercise and I draw a circle, it's important to not see that thing as a circle, but see it as a sphere. And with this sphere, I can do this thing where I can place a dot on it. This is like a pole. Or it's and maybe a better way for me to explain how this pole works. So I'll just do one for now, and the pole will have an opposing pole as well, which kind of goes through the center of it, and so it swallows it up like that. So let's see if I can give you an exercise for just drawing the poles on these spheres. So if I stick needles into this sphere, right? Like if I just put one dead center, it's gonna sit like that, and these ones will be a little bit longer. These ones, actually, maybe the best way for me to explain this is maybe not think of them as sticks, but think of them as thumbtacks. So a thumbtack just touching the edge is going to go like that, whereas a thumbtack over here is going to be like that, and another thumbtack. So these thumbtacks, they always line up to the center. It's a key thing of them, and the amount at which the circle begins to turn to the side, right? Like the things at the circles, they turn to the side and become smaller as they go over this horizon, right? So there's a horizon which they're passing over, and I would suggest taking just one sphere, just get one sphere and begin placing the thumbtacks over it, and just, you can eyeball it, it won't be perfect, but get the sense of that general trend of the thumbtacks turning away, and also the pole getting longer and longer, right? And again, like you could just go over the entire sphere, just drawing the needle part of the thumbtack. In fact, you may even find it easier if you split up the task into these two stages of just pin cushioning this whole sphere, right? And whenever they cross over the horizon, right, you see, like you get to see the horizon will block off that pin, right? So you'll start to see the underside of the pin like that, right? Whereas here at the very edge of the horizon, you see a flat line like that, because you're seeing you're seeing this thing, you know, you're seeing the underside, or you're seeing it edge on, or you're seeing it on top, like that. So I would say, yeah, you can do the thumbtack exercise, and conversely, you could go over the whole thing and just drawing the ellipses as well, right? So the two are obviously they're intertwined, right? They're interdependent, and you can't have one without the other. Or rather, I would say that, you know, there's the relationship between the length of that pin and the aspect ratio of the head of the pin. They're intertwined. So what I mean by aspect ratio is, if you look at a square, right? A square has an aspect ratio of 1:1, right? That's what they talk about when they say this is the ratio of width and the height. And then if you, let's say, look at cinematic aspect ratios, right, you'll find you get like 16:9, which is like the cinematic type, and then you have 4:3, which is for most traditional monitors, right? So that's aspect ratio. It's how wide, you know, or it's the comparison of the major axis and the minor axis of that ellipse, right? So that's what I'm saying, is that here there is a relation between where on the sphere you're choosing to place the pin, how long the pin is going to be, and the aspect ratio of that pin. So maybe it's actually better to just, again, you can take a sphere, and you can look at just putting the dots down, right? So putting the dots down, as you get further towards the edge of the screen, they become closer together in a concentric fashion or manner, whereas in the center they're much more sparse. And when I mean a concentric fashion, I mean that if I was to draw concentric circles on this, the spacing between the circles becomes tighter and tighter as you reach the edge, right? And by that I mean the distance between here and here and here, right? So I mean that distance begins to get tighter and tighter and tighter. And the reason for that is if you look at a cylinder from the side, so if we look at a cylinder from the side, so actually I'm going to slightly draw, I'm going to draw it in a slight perspective. Okay, right. So seeing a cylinder from a side-on perspective like this, right, if your vantage point is over here, so let's say your vantage point's here, that means that if looking at the sphere like so, right, and we put even lines over this whole thing, so at 45 degree I'll put another one, and then at 90 degree I'll put another one, right, then what's happening is this. Actually, I'll subdivide it one more time. Okay. This is what happens. Look at the spacing, right? So the spacing is greatest, supposed to be greatest about here, and then it gets narrower and narrower and narrower, right? Because you're beginning to see, if you're over here, if your vantage point's here, and mind you, this effect kind of, it lessens when you get further away. It's much more pronounced when you get closer, right? But if your vantage point is here, then when you look at things on a perspective plane, right? You put a perspective plane down like that, you're going to see that the projected points, well, I guess in the case of this one, the projected point is going to be here. This one is going to have a point that winds up here. Projected point winds up there. And I imagine that would be the projected point right there. And then over there. Okay, so your projected points, look at the spacing of the projected points. Right, so again, you have a great deal of space here, right, in the middle, less space as you reach the edge. So as a result, you know, if we apply that to the sphere, it's the same way. It's that it works in all axes, right? You can see that there's greater amounts of spacing, less and less and less. And because it's a sphere, it applies in the horizontal, applies in every direction, every possible direction. And so you use that to figure out the spacing of your dots. So your dots become widely spaced over here in the middle, and then they become closer and closer together as you reach the edge in a concentric fashion, right? The concentric distance, or the radial distance, begins to decrease as you reach the edge. And so once you have those little dots down, then you can begin thinking, okay, well, how long will that pin be, right? So start thinking, the pins get shorter as you get closer to the center. Right. So now that I've done several of these pins, right, then I can start fiddling with the aspect ratio. Okay, so they're thumbtacks, right? So you need to get that feeling. You need to be able to look at a sphere and be able to gauge the roundness of that sphere. And once you can gauge that roundness, then when it comes time to choose a pole on the sphere, so I can choose like a north pole, right? Choose one point that goes through here. I know that the center of the sphere is about here, and that pole, if it just penetrates through the sphere, there's the opposing pole. Right, so this is all traveling, this is all penetrating through the sphere. And another thing that I've done, you'll notice, is that the distance between these two poles, the distance is greater here, and it's less there. In truth, what's happening is, if you take an object like like this, okay, or yeah, okay, so let's say we take an object like this and we look at the dividing line, we say there's that much distance, and maybe there's, so the distance between this dark part here and that other area, looking at it straight on, it's the same, but when I do this, right, look what happens. This side here gets longer, this part is shorter. It's foreshortening. So when you know that, now I can say, well, that's where the pole lances through. Figure out the aspect ratio of the ellipse. I'm going to draw these, I'm going to draw them as ellipses, not as a spiral, right? But down there, there's, oops, an ellipse that goes through like that, and one that goes through here. Doing it as a spiral is just a matter of joining, right? The other thing I'm doing is I'm altering the diameter, of my line. My line gets thicker. And also, because that area is further away, I use a tighter spiral, right? Because this, the area, the back side of the sphere, I use a tight spiral. As I get closer, I use a thicker spiral. So doing this. That's what goes on when I draw these spirals, right? Is that I'm using tight spirals, thin line. Once I crest, as I bring it from back to front, I use thicker pitch lines, like thicker lines, and also the space is thicker. And then if I just have one going straight on, right, the same thing applies, except because it's straight on, it's going to be circular. The aspect ratio will be circular. If I look at it from side on, then I get this. Right, something more like that, except really it needs to conform to a circle. So, and take your time, right, when you're looking at it. If anything, looking at this, like this would be, if you saw it from really far, it would look like that. If we got closer to it, though, then I would do something like this. Right, because we're seeing what's happening is a perspective effect. So what happens is this. If you're looking at a circle straight on, right, and sure, let's say this is just, if I draw it as a 2D thing, and our vantage point's over here, right? So our vantage point's over here, and we're looking at it this way. Now you're seeing the underside, right? You're seeing the underside of the ellipse. This is what's happening, right? It's not an orthographic, it's a perspective. You see the underside of the ellipse, you see this one straight on, this one you see the other side, right? You see the underside of the other ellipse, right? So that's why I have to do that. And the other thing is that you'll notice that I put the poles behind. This pole here is sitting behind the horizon. The horizon is the thick line here. So all of this stuff that you see on this edge, yeah, everything that you see, this is all hidden. You don't get to see that because it's sitting underneath the horizon. That's all underneath the horizon until it wraps around and comes over, and then it goes over the edge and it's over the horizon again. And then it comes out and then it goes under the horizon again, right? So there's this, this is what you see, something. It goes up and then it comes over and it goes around. It's going behind and it comes in front. It goes behind and it comes in front, and then it goes over the horizon again. So, and again, if we look at this diagram here, right, this is the horizon, right, that you see from your vantage point. And so the poles are sitting underneath the horizon. That's why this is happening. Okay, so yeah, there's actually a lot that goes on with these, with this particular exercise. It's I make it look easy, but I mean, there's a lot that I keep track of, and yeah, that's pretty much how to do it. Anyway, hope that helps, and I'll talk to you all later.